So the idea in this video is that we need to be able to look at the graph of the derivative of a function and be able to tell things about it, like be able to find where the relative maxes and mins are and where the points of inflection are. And in particular, I want to talk about doing this with a calculator. On each of our assignments, we've had problems where we've done this, but we've been given a graph or we've done the problems analytically by hand. We haven't done a lot with a calculator. So just as a quick review, if you are given the graph of a derivative, how do we find the x-coordinates of relative maxes and mins? I hope you remember that there are two things we're looking for. One, we're looking for where the derivative is 0 or undefined. And then the second thing is that we also need where the derivative changes from positive to negative. And if the derivative changes from positive to negative, that means you're looking at where the function changed from increasing to decreasing, so that's a relative maximum. Or where the derivative changes from negative to positive, and this was a relative minimum. You may remember that we had one other thing in there. There was something called a saddle point. And a saddle point is where the derivative doesn't change from, like it goes from positive to positive or from negative to negative with a critical number in between. I'm not going to focus on those right now because the exam tends to not ask about them. So really I just want on the relative maximum and relative minimum. So for our purposes, we're going to find these things by looking for the zeros of the function. And so on the calculator, we'll use the zero feature, which is in the, if you look over in the calculator, it's on that second trace menu. If we go second calc, it'll bring up the zero option here. So that's how we're going to do that, right? So the zero feature, which is in second trace, right? So what about the coordinates of points of inflection? And I know points of inflection is kind of a new topic for us, but how about that? I mean, where do we find points of inflection? Points of inflection happen where the function changes from concave up to concave down. What does that mean? That's where the derivative changes from increasing to decreasing, or vice versa. Right? So I mean, think about that for a minute. If you're looking at a picture of the derivative, if you had a derivative in front of you, what would you be looking for? You'd be looking for places where it changes from increasing to decreasing or decreasing to increasing. Right? Well, if you think about that on a function, that means your function is going up, your derivative is going up, then going down, or going down and then going up. And so that sort of leads us to the powerful statement that points of inflection of an original function have the same x-coordinates as max and min values of the derivative function. Right? And I'm hoping to clear this up by having us look at a specific example. But the short of it is, if you've got the graph of a derivative, you should look for the maxes and mins of that derivative to find the points of inflection of the regular function. I wouldn't be surprised if you guys need to listen to these things a couple of times to get that stuff to sink in, but we also are going to look at an example right here. So I want us to look at this function, x cubed plus x squared minus 4x plus 3. And I've got a few steps here. First of all, I want to graph the function on the calculator. So we go into y equals, I've already typed it in, there it is. From there you can either hit graph, and if your graph doesn't look like this, if your graph looks wacky, I've always said use zoom 6 to get to a standard zoom window. And then once you're in a standard zoom window, we can find things more easily. So, graph function calculator, yay, we did it. On the test, sometimes I'll ask you guys to sketch these. I swear I can type. After that, so now we want to find the x-coordinates of relative mins and maxes of the function, right? So keep in mind, and this is a very small point up here, this thing right here is already the derivative. Like, I've given you the derivative of the function, so this thing is the derivative. So if we want to find mins and maxes of the original function, that's where the derivative is 0, right there, and where that derivative changes from negative to positive or positive to negative. And so, as we're looking at this, the only place where that happens is this x-intercept, right? So we are looking for x-intercepts where the sign changes. Right? So for us, we need to find that value right there. We can go into our calculate menu, bring up option 2 to find the 0. The questions here are asking for left bound and right bound. I'm looking at this on the calculator saying that's about -3, so I'm just going to type in a left bound of -4, and that sort of puts the left bound cursor over here. The right bound, I don't know, I'll say -2. For the guess, you can usually just hit enter again, and it'll come back and tell you, hey, cool, that 0 happened at -2.806. Right? So x coordinates are relative max and mins. We have x equals -2.806. Will give us a relative. So the question for you is that a max or a min? Right? Well, the derivative here was negative and changed to positive, right? So this gives us a relative minimum because the derivative changes from negative to positive. And if you want to, you can even say, which means that the original function f changes from decreasing to increasing. Okay, so this whole thing is the answer that I'm looking for. I want both a value, I want whether it's a min or a max, and I want justification as to which it is. All right. The last question I'm going to ask you, which is going to end up kind of being a two-part question, is for us to find the x-coordinates of points of inflection. Right? And I mentioned a few minutes ago, points of inflection are the same as the maxes and mins of the derivative. Because you can see this point up here is basically where the derivative is changing from increasing to decreasing. This minimum down here is where the derivative is changing from decreasing to increasing. The question is, how do we find that thing? Well, you're in luck. In that same calculate menu, if we go into second trace, there's an option for finding a minimum and finding a maximum, right? So min or max. So the first one we had there was a maximum, so I'll go down and pick maximum. Did not want that. And you can actually just hit 4 to bring a maximum. It's now asking, like, okay, so what's the left bound? Same deal. This thing up here seems to be at about -2, so I'll say my left bound is -3. I'll say my right bound is like -1. It's just like finding a 0, right? With a guess, you hit enter again, and it'll come back and tell you that maximum happened at -1.535. Will give a point of inflection because the derivative, whoops, sorry about that, the derivative changes from increasing to decreasing. The other one over here is this minimum value, so we'll go and find that one, second calc. This time minimum is number 3. Same deal, a left bound, 0 looks like a good left bound. A right bound, I think we could get away with saying 2. And then enter, comes back and gives us that minimum value. So we also have x equals 0.869 because the derivative changes from decreasing to increasing. These things here, again, with justifications, are the answers that we're looking for, and what I'll be wanting from you. So that should be all you guys need to get through the homework tonight. Good luck with that.